Alright, let's begin. So we're going to start covering all the critters in this game. First one is the Centipede with a finite state machine. So on start of the game, it creates all of its different move states. Let's see here, the game was started. This was called once. If I were to change the mode, it's not called again. All the states are created at the start of the game, and then all the segments, and then are deleted at the end of the game. So each of the states have an offset based off of which way it needs to move. These offsets have position offsets, rotations, and an index. The index is used so that the centipede knows when it reaches the end of its state. When it reaches the end of the state, it needs to know when it gets what its next state is going to be. So it gets the row and column from the head, and then it checks to see if it's not going to check off the list. So if the column is at the max value, then that means it's off the list. So a poison mushroom cannot be found. So if it's not that and it finds a poison mushroom, then it will start its poison state. Otherwise, it has to check to see if there's an entity or if it is at the edge of the screen. If either of those is true, then it needs to rotate. If it's on the bottom of the screen, then it rotates upwards. Otherwise, it rotates downwards. If none of that's true, it just repeats its current state. So it just keeps moving right and down. Other than that, the Centipede head and segment are both parented to the Centipede base class. This has some similar variables and getters. The Centipede head has two initialized, one for promotion, which I'll cover with the segments, and one for when it is either a solo or the starting head of a longer segment. So it defaults its variables. If it's a solo head, then its length is 0 and it randomizes its column. Otherwise, it will create segments behind it based off and get the length from its spawner, which I'll cover in another video. After that, adds it to this list, gets its position, and updates the sprite. In the update, if it is not at the end of its current state, it will get its offset x and y, multiply it by the speed, get its rotation, update the position, and then it will increment the current offsets based off of its speed. So if its speed is 1, it will go 1 at a time. If its speed is 2, then it's going to do every other offset in the array, etc. This allows us to have dynamic speed without centipedes. When it reaches its max index, it will get its row and column. Then it will get the next state based off of the function. Again, we'll cover that with the promoted heads. And it gets the offset and resets its index. When it collides with a bullet, it will check to see if it's not at the bottom of the screen, because we can't make mushrooms at the bottom of the screen. If it's not there, then it checks to see if it's going left, and that determines whether or not we will create a mushroom on the left or the right, assuming that a mushroom or other entity does not already exist in that position. If there's a segment behind it, then we have to do promotion, which again I'll cover later. Then we move it from the list, create an explosion. If it collides with the blaster, we destroy the blaster, detach it from whatever might be behind it, and mark for destroy. The segment has two different initializers, one for when it's behind the head and one for when it's behind the segment. They are nearly identical with the exception of which pointers are initialized. So if it's behind the head, the p head is initialized and next is null. If it's behind the segment, then p head is null and next is initialized. When if its length is not 0, it will create the segment behind the segment. And it will decrease the length until we reach 0. And then it will command the segments behind it. So this command segment as well as the command segment as head, which we have right here. This gives whatever segment is behind it in both cases. So both of them have the same thing. Both of them will give it the segment its next state. This next state allows the segments to know what it needs to do next without giving it access to the finite state machine. So only the head has access to the finite state machine. All the segments will receive its next command based off of what is in front of it, and that will go all the way up to the top where the head will tell it that the next state is from the finite state machine. So when we are in the update, it's the same thing here. when we get to the max index, instead of calling the p current state get next state, we just set it to the next state the segment knows it is based on what the segment in front of it commanded it to do. Once we do that, we have to receive its new next command based off of what the segments in front of it is currently doing. Colliding with the mushroom, again, check for if it exists and if it meets the criteria. After it collides with the bullet, we also have to detach it from the centipede, so we do this to remove it. If there's a segment behind it, we have to promote it, and then after that, we remove it from the spawner and create an explosion. For the blaster, same thing, we have to detach it from the centipede and kill the blaster. For promotion, we have we take the segment behind the segment that just got destroyed. We detach it from the centipede as well. And then before we destroy it, we promote it to a head. So promoting it to a head will make it so that we take the position, move state, and step of the current of the promoted segment, and we update the head to mimic all of it. So its not its offset. Its position is set to what it was given plus its offset. Its rotation is based off of a new offset. The current offsets, the current state, current state is based off of what the promoted segment state was. Then we have the move offsets. We set its promoted to be true because it's now a promoted head. Then we get the index. If there's a segment behind it, we have to stagger it. This staggering ensures that it follows the command of the new head. So we just update its index and offsets to be whatever the step is. After that, we set its row and column. And then now in the update, because it is now a promoted head, the promoted head will command the segments rather than the segment asking the head. This makes it so that the head is seen before the segments in the update order. For the spider, we have the row and column. We randomize whether or not it's going left or right. If it's going left, then we make it a positive. Otherwise, it's negative. This will make it so that we know whether or not to flip the sprite, as well as determining its horizontal speed or horizontal direction. We randomize its initial movements, and then add it to the list. We have every time it reaches a new grid cell vertically, we have to check to see if it's about to go off the screen. So what we do with that is we check to see if its max row, if its position is greater than the max. If it is, then we invert it. Then we also check to see if it's below. If it is, we invert it. And then we change its position. If its position would put it off the screen on either side, we destroy it and remove it. The alarms, we check to see when it's met, we check to see if it has some sort of non-zero value. If it does, then that means we have to stop its movement so it can just bounce up and down, and then we redo the alarm. When we go back to redo the alarm, we check to see if it should change. So it has a random chance to change directions. If it does, then we bring back the horizontal direction based on what the horizontal was before, and then we set the alarm again. For vertical, whenever this is met, we just invert it. When it collides with the blaster, we destroy it. When it collides with the bullet, we destroy it as well with a big explosion, and we remove it from the list. If it were to come in contact with a mushroom, then it will just destroy the mushroom instantly. Yeah. So next up is the flea. For the flea, it will initialize it. It gets a random column, randomizes a column position. Every time it reaches a new grid cell, if it's not in the last row, then we will see if it can spawn a mushroom, and then update its position based off of its speed. If it ever reaches the bottom of the screen, then we remove it and check to see if we need to spawn another one. Next up then is the spawning. When it does successfully spawn a mushroom, we have to check to make sure there's no entity in its position. If there is an entity, we don't create a mushroom, otherwise we do. When it collides with a bullet, it gets damaged. So if it has not been damaged yet, then it becomes damaged. If it is damaged, then we remove it and check to see if we need make a new one, as well as make an explosion. Collides with the blaster, then the blaster is destroyed. And when the flea is hit, instead of checking for mushrooms, it is just going to move faster. So instead of its normal speed, it moves at whatever the multiplier is. For the scorpion, we have similar to the flea, except instead of column randomizing, we randomize the row. And then we have a slight offset so that it can't spawn in either the place based on high score. We randomize its direction, and that will change its scale. And then we get to the update. So if it ever reaches a new grid cell, we check to see if that grid cell has a mushroom in it or entity. If it does, then we poison it. Other than that, we move it based on which side it's facing. So this will make it move to the left, and then if its position is less than 0, we remove it. Otherwise, move to the right. And if we ever make it to the edge of the screen, we remove it. Set position and update. If it collides with the bullet, we make the explosion and remove it from the spawner. And that's it.